Hello, am I audible?
Yes.
Yes, भैया.
Okay, I'll start. So, hi everyone. Welcome to the post-contest discussion meet for CodeBrew Freshers Contest. Now, ideally, we would have kept this meet right after the contest, but considering that you guys have exams coming up soon, we decided to do it today instead. And we'll keep the discussion as concise as possible. So first of all, let me just explain the plan of competitive department of Coding Club over the next few months. We are going to hold contests on a regular basis, which will help you get better at competitive coding. Of course, coding is a must-learn skill for everyone who wants to get a good placement later on, and it's best to start in the first year itself. Now, let me reveal the final results. The top 5 freshers in the contests were Harshit, Bhaskar, Dev, Saksham, and Abir. Congratulations on your splendid performance in the contest. Moreover, from seniors, the highest 2 ranks were bagged by Akash Gupta and Krishna Jain, both of whom managed to solve all problems in around 1 hour only. We hope all of you enjoyed giving the contest. Now, without further ado, let's begin the discussion of solutions. First, I hand over the mic to Mridul for discussing problems A and B.
Thanks, Tanveer. Please change the slide. Thanks. So I just give an overview of the first problem statement. For the first question, you had n objects and you had to find the number of containers such that all the objects could be fitted in the containers. And there was a constraint that a container could hold a maximum of k objects. So I think it's pretty straightforward. You would want to fill all the containers first, right? If you have one container, you would like to make sure that it's filled before you start on with the next container. So therefore, fill each container first till it reaches its maximum capacity. So the first K books go in the first container, the next K in the second container, and so on until the total and therefore the total number of containers needed would be CL of n by k, right? Because if the last container, it's not necessary that the last container would be full. Then we change the slide to problem B. Problem B. Right. So the second question, the simplified version of the second question was that you could use a maximum of n bricks and you had to build a staircase such that the stairs are an increasing order of heights and you had to maximize the number of stairs. So intuitively, you would want to minimize the number of bricks used for each stair, right? The first step would use 1 brick, the next step would use 2 bricks, and so on. Therefore, optimally, each consecutive step should contain 1 brick more than the previous step contained. So the condition would be that we would keep adding more bricks so long as the number of bricks used till now plus the number of bricks needed for the next step is less than or equal to the number of bricks available to us. We keep adding bricks so long as the above condition is satisfied. So you can simply simulate the whole process using a while loop. Can we please change the slide? Yes, you can simulate the whole process using a while loop, and if you're having difficulty with the implementation, the code is provided here. So Tanveer, please continue with the discussion of the next questions.
Okay, so we're going to skip problem C for now because C and G were both essentially the same problem in easy and hard versions. So we'll discuss C and G together later on. I'll go to the next most solved problem right now, which is D, Elder Ring. Now, if you simplify the problem statement, you can just realize that there are M ranges. We are given M ranges, and the ranges are obviously in a pair. They're of the form L to R. And in the question, we have to find out how many numbers come inside all these ranges. So if we have to find the numbers that come inside all these ranges, it's basically equal to taking the intersection of these ranges. Like think of it in terms of set theory or like a Venn diagram. We have to find numbers. So if we take the intersection, let's figure out how to take the intersection. This is just equal to the maximum of all the left numbers in the range and the minimum of all the right numbers in the range. Now, as a side case, if the maximum of L comes out to be greater than the minimum of R, that means that the intersection is a null set. In other words, there will be no range. For example, let's say one of the ranges was 1, 2 and the other range was 3, 4. So obviously no number comes in both the ranges. So the intersection is a null set. You can see the implementation here. The left side is just, I've just taken the input in the left side. In the right side is the real part. First, we initialize L and R. L is initialized to a very large value and R is initialized to a very small value. Then inside one loop, we try to minimize L and maximize R as much as possible. And then we just have the condition. If L is greater than R, then we output 0, else we output the range. Okay, moving on to the next problem. By the way, if there's any doubts regarding your specific code, then after the meet, we'll be here for as long as needed. And you can screen share and discuss your doubts with us, whatever you want. Okay. Problem E, hostel cleaning. Now, in E, the problem statement may have felt a bit difficult at first, but there were some major hints to be taken. First of all, it was written that we have to minimize the number of sweepers. Moreover, K, which is the number of rooms that each sweeper can sweep, it is a factor of n. Now, this should be enough to realize that exactly n by k sweepers will be hired because well, once again, k is a factor of n. Each of them will be at a distance of exactly k from each other, and only that way will be able to hire the minimum number of sweepers. So now the problem is, knowing that we have to hire n by k sweepers, each of them at a distance of k from each other, we have to minimize the sums of costs of these sweepers. So there are k different sets, and we need to minimize the cost. Take a look at the approach to do this right here. Left side, once again, it's just the input. On the right side, we initialize an answer array, which is of length k, so for k different sets. And we just use the modulo operator to add to this answer array. And then if we can find the minimum value of the answer array using whatever method, there are standard library functions for that too, we can just output that and get our answer. Okay, now Shivansh will discuss problems F and G.
So, hello. So, yeah, I'll discuss problem F, no internet IPC. So, what does the problem say? You have some n computers, but only one of them has updates installed. You have 2 patch cables. You can install an update on a computer by connecting it with an updated computer through a patch cable. So, initially, you have one computer with updates installed. From this computer, you can install updates on one new computer, making a total of 2 updated computers. Now, using these 2 computers, you can install updates on 2 new computers, making a total of 4 new computers. So now suppose you had only 3 patch cables. So in the next hour, you'll not be able to install, you'll only be able to install updates on 3 new computers. So you can double the number of updated computers every hour until the number of updated computers exceed the number of patch cables. So we can stimulate this process in a while loop. Next slide, please. So yeah, so currently you have one computer and you spend 0 hours, and you'll input the number of total number of computers and patch cables. So while the current number of updated computers is less than the total number of computers, we'll increment the value of currently updated computers by minimum of cur and number of patch cables. And we'll just do this process in 1 hour. So we'll increment hours by 1. Okay. Let's move on to the next problem. Yeah. So dualites and pane. So what does the problem say? You have to repeatedly pick the largest number and decrease its value by 1. But you cannot pick the same element 2 times in a row. So let's take an example. Suppose the largest element, say x, is 24. And the second largest number is some y. So you pick x and decrease its value by 1, making it 23. Now, if the second largest element, y, is less than 23, then x is still the largest number. But we cannot pick x again. Hence, it's impossible to complete the task. So, only if y is 23 or 24 can we pick it. Suppose y is 23. Now, we can pick y, make it 22, Then again we can pick x, make it 22, then again y 21, x 21, and so on till x equals y equals the third largest element z. So now we can pick x, y, and z and do the same process again. So eventually we can decrease all the elements to 0. So we can say that if y equals, next slide please. So for problem C, we can eventually say that if y equals x minus 1 or y equals x, we can always make all the elements of array A equal to 0. So this was a solution for problem C. It's quite simple. Now for problem G. So basically now we have to implement the whole thing that I just said. So suppose we wait. So now for problem G, we'll output the index of x until x equals y. So basically, like we'll print x, decrement it by 1, then we'll again print the index, and we have to print the indices of these numbers. So how many times do you think the last number x would appear? Until the number x is equal to y by decrementing it by 1. So the number of times it should appear is x minus y times. If we sort the array, we can say that an should appear an minus 1 times. Secondly, now we know that an and an minus 1 are equal because we've completed one iteration. So we will print an and an minus 1. Now, how many times we have to print an and an minus 1? So if you think carefully, you have to print an and an minus 1, an minus 1 minus an minus 2 times, which is, I think I should explain with an example. Can you move to the next slide? So let's take an input array as 42142. So we can convert and we can store this input array as pairs of elements and indices because we need the indices of these elements. So and let's insert a 0, 0 for stimulating the process easily. That's an extra pair that I've inserted, 0, 0 in the starting. So we have 4 at one index, then 2 at second index, then 1 at third index, then 4 at fourth index, and then 2 at fifth index. So once we sort this array, it becomes something like 0, 0, 1, 0, 0, like 0 element in the 0th index, then element 1 in third index, element 2 in second index, element 2 in fifth index, and so on. So how will you implement this part? You can just take an array of pairs and you can assign an extra value at index 0, 0, 0, and you can input the rest of the values and you can sort the array. Now, so let's see how the iteration will work. In the first iteration, we'll store the index of ARR5, which is 4, right? So we'll print the array of indices how many times? 4 minus 4, 0 times. So we'll not print this any number of times. Now, we'll move to AR5 and AR4. Basically, AR5 and AR4 were equal from the starting. So we did not have to print AR5 any number of times. So now what is the indices for AR5 and AR4? 4, 1. We'll sort this indices for printing the lexicographically minimum value. Because in the question you were asked the lexicographically minimum. So sorting was necessary here. Now, how many times do we have to print this? 4 minus 2, 2 times. Because, see, the last two elements are 4 and 4. And the element that is lower than that is 2. So you'll print 4, 4, then you have to get to 3, 3, and then you can get to 2, 2. So basically, you have to print AR5 and AR4 2 times until it becomes equals to AR3. Then in the third iteration, we'll store the indices of AR5, AR4, AR3. That is 4, 1, 5, and we'll sort them. And we'll print them again 0 times because AR3 is already equal to AR2. So we don't have to print them any number of times. We'll also include AR2 in our iteration. So we'll store the indices of AR5, AR4, AR3, and AR2 this time, and similarly sort them. This array of indices will be printed 1 time, and so on. So basically, you can see the answer is 0 times 4. So 4 is not printed. Then 2 times of 1, 4. So 1, 4, 1, 4. And then you have to print 1 time 1, 2, 4, 5. So 1, 2, 4, 5. And then last 1 time 1, 2, 3, 4, 5. So you can see the code of this, how have I implemented this. So let's say you move from the last index. Initially, we have the last index, and we make an array indices, which will store the indices of all the elements that we have to print in this iteration. So we'll firstly store the indices, all the indices in the indices array, which we'll do by iterating from n to I and storing these values. Then we'll sort these indices, as I said in the above iteration process. Then we'll print this array how many times? arr I dot first minus arr I minus 1 dot first times, as I explained in the above process. So now we can move to the next problem. Tanveer, you can take over.
Okay. So this is the last. This was the problem with the least number of solves. But it was actually, well, it's not that hard if you just get the key idea here. Now the key idea is you solve the problem in reverse. So you're given an array, you try to figure out which is the last element that would have been inserted into this array. Now, if we try to solve the reverse problem, then it can be rephrased in this way. We have n elements in a row, and if the kth element from the left is equal to k itself, that is, if the element value is equal to the index, then we can remove this element from the sequence without any issues. Now, the other key idea is we have to remove the rightmost element that can be removed in this way. Because think about it, let's say there are two elements, there is 3 and there is 5 in the sequence. If we remove 3, then the index of 5 will change. Index of 5 will instead become 4, and now we can no longer remove that element ever again. So it is best to remove the rightmost element at any given point. So let's see how to implement this. The actual implementation is a bit lengthy, so I've just given the pseudocode here. Now ARR is our array of integers, n is the length of the array, and answer is initially an empty array. This is where we will append our values. Now for I in range n, this basically means we keep a for loop with n iterations. Now, in each iteration, we find the rightmost element in the array such that the value is equal to the index. Of course, here I've gone for I plus 1 because of zero indexing. That depends on your implementation. So we find the rightmost element that can be removed. And we remove this element from the array and insert it into answer. Now, if no element exists such that ARR of I is equal to I plus 1, then we can just output no, because it was not possible to simulate this sequence. Else we can output yes, and of course we have to, since we went for the reverse problem, to output in the end we have to print the elements of answer in reverse order. So yeah, that was it. See you guys next month for the second freshers contest. That will be a little higher difficulty, and I hope you guys enjoyed, and if there's any doubts you can ask now.
Can you tell the 16th test case of the 7th question?
You mean problem G?
Yeah. The second
sure,
row, right?
let me take a look.